Hey everyone, welcome to your Play Pause It for the week. We are actually going to be finishing up the notes from our live class from last week. So go ahead and grab those notes. And remember, last week we reviewed or learned and reviewed the quadratic formula. Don't forget, this formula is on your formula sheet, which you can use in your class for any test, any quiz. It will also be available to you virtually on the SOL. So you do not have to memorize this formula. And so for the rest of the notes, we're just going to talk about one other tiny piece, and it comes from the quadratic formula. And it's called the discriminant. So the discriminant is just a fancy word for this part of the equation. And we denote it with a capital D here. And it's just the part that's under the radical. See, right here. And this part of the quadratic formula is very special because it will help us determine the type of roots or solutions or intercepts a polynomial will have. So if we plug in a, b, and c into this equation and it's less than 0, so it's a negative, that means there are no real roots, which means the graph doesn't touch or cross the x-axis at all. Now, when you get into some higher mathematics classes, you'll learn how to find the imaginary roots, but for now, we are not going to be finding those, and we will just note that there are no real roots if it's negative. If it's exactly equal to 0, that means there is one real root. So it touches the x-axis, it just like skims it. And if it is greater than 0, that's kind of what we're used to, right? Where it crosses the x-axis twice and we have two roots or two solutions. So it's a little test that we can do to determine what kind of solutions a polynomial is going to have. So let's try it. Here's that discriminant. Now this is not specifically on your formula sheet, but the whole quadratic formula is. It says, what type of roots does this have? Let's find them. So our quadratic is given in standard form, right? The exponents are in decreasing order, so we can easily pull off our coefficients a, b, and c. So a is 1, b is 4, and c is negative 5. So we're just going to plug those into our discriminant formula, b squared minus 4 times 1 times negative 5. And let's see what that is. Remember, you can use your Desmos. 4 squared is 16. Negative 4 times negative 5 is positive 20. And we have 36. So in fact, 36 is greater than 0. So that means there are two real roots. And if we were to graph this on the Desmos calculator, you would see, let's look. I'll clear my other workout. Okay, x squared minus 4x plus, oops, did I put it in wrong? Hold on. X squared plus 4x minus 5. I have my signs backwards. That changed everything, didn't it? Here we go. Okay, two real roots. It doesn't mean that there won't be decimals. These are just whole numbers, but they're real numbers. They're crossing the x-axis at 2 points. All right, let's look at another one. I'll put it up here. Again, we have this in standard form. So A is 1, B is 2, C is 1. And we'll just plug it in. 2 squared minus 4 times 1 times 1. And you get 4 minus 4, which is 0. So if the discriminant equals 0 exactly, that means it's going to exactly touch the x-axis at 1 point. So let's look at this graph. X squared plus 2x plus 1. There it is. It's exactly touching right there at negative 1. How many and what type of solutions? Okay, so these questions, they don't want you to actually solve. They're asking for how many and what type. So first, don't forget, we want to get it into standard form. So let's move the 18y and move the 4 to the other side. And we'll get 5y squared minus 18y plus 4. Now we can find a is 5, b is negative 18, and c is 4. If you don't put it in this order first, you won't get the same answer. So make sure you do that. Here's our discriminant. So negative 18 squared minus 4 times 5 times 4. I have no idea what negative 18 squared is. So I'm going to grab my calculator. I have it on my phone. It's 324. That's a big number. And then we have 5 times 4 is 20. And 20 times 4 is 80. So minus 80. So we get 324 minus 80 is 244. 244 is greater than 0, so we're going to have 2 real roots. Let's look at the graph, because that seems, I wonder if, whoops. Okay, see if I could just select it and paste it. Okay, 5x squared. I'm just going to put it in exactly how we had it. There it is. There's our 2 real roots. They're decimals. That's totally fine, but they're real numbers. Oops, it's a positive 18. Why do I do that? It's like my brain can't even store. Okay, there we go. Still 2 real roots. Okay, last one. How many and what type? Don't forget to get this in standard form. So we'll have 2c squared minus 16c plus 32. So a is 2, b is negative 16, and c is 32. So we'll have b squared minus 4ac. Negative 16 squared minus 4 times 2 times 32. This is 256 minus 8 times 32 is 256. And you get 0. So the discriminant is actually exactly 0. That means it's going to touch the x-axis. So let's look. Forget if it was plus or minus, y'all. Minus 32. Okay. Did I do something wrong? Hold on. 2x squared equals 16x minus 32. Okay, so this is good. This is a great example because this is showing, hold on. It's showing a root right there. Let me see what this says. 2x squared minus 16x plus 32. Should be the same thing. Oh, what? Wait, did you see that? Did I type it in wrong before? What? Y'all see what's happening? This is interesting. These should be the, hold on. Huh, I would like to talk about this next time I see you. That's interesting. It really should be the same thing. If I put 0, then it becomes the same thing. Okay, for now, the purple graph There's gotta be something I typed incorrectly somehow. Weird. Okay. It does touch it just one time on the x-axis there. We're gonna talk about this in class and see if anyone else can figure it out. Why this looks linear and this is a quadratic. Obviously, it has to do with the way it was put in, but when you put 0 here, then they both become linear. Okay, good to know. And we should talk about that more. Thanks for sticking with me for the rest of our notes. And I will see you in live class this week for to finish up Unit 4. I'm sorry, Unit 3. We're basically gonna wrap up Unit 3 with some review in live class. So there's nothing else new to learn in Unit 3. Just gonna wrap it up and keep practicing. So I hope you all have a great first few days, and I'll see you soon.